This video is on horizontal motion in one dimension. Question 1. A car starts from rest and speeds up to 35 meters per second in 12 seconds. So V initial is 0, V final is 35, delta t is 12 seconds. Part A, what is the average acceleration of the car during these 12 seconds? So take a look at these two equations. U is initial velocity, V is final velocity, A is acceleration, T is duration of time. Plug in for the variables, we get A is 2.92 meters per second squared. Part B, what is the total distance traveled by the car during these 12 seconds? So take a look at these two equations on the top. U is initial velocity, V is final velocity, A is acceleration, and S is the change in displacement. S is equal to S final minus S initial. Plug in for what we know, solve for what we don't know, which is X final. The car then travels at a constant speed of 35 meters per second for 900 meters. So part C, how long was the car traveling at this speed? So it was traveling at 35 meters per second for 900 meters. So take a look at this equation. S is the change in displacement. S is equal to S final minus S initial. A is acceleration, T is duration of time, and U is initial velocity. Plug in for what we know, solve for time. Question 3. The car finally slows down from 35 meters per second to 15 meters per second in 4 seconds. What is the average acceleration or deceleration of the car during these 4 seconds? So U is initial velocity, V is final velocity, A is acceleration, T is duration of time. Solve for A. Part E, what is the total distance the car travels during these 4 seconds? So U is initial velocity, V is final velocity, A is acceleration, S is change in displacement. S is equal to S final minus S initial. Solve for X final. Part F, what is the total distance the car travels since it started from rest? So you could just read the problem and look at some of the solutions to obtain 10 meters. Part G, what is the total time taken for the car to travel since it started from rest until it reaches a speed of 15 meters per second? You could just read the problem, see the solution to some of the problems to get 41.7 seconds. Part H, use a pencil and ruler. Should say use a pencil and ruler. Draw a displacement versus time graph, a velocity versus time graph, and an acceleration versus time graph for the car. So when we start from rest and we speed up, the slope increases on a displacement time graph. Then when we move at a constant speed, the slope is constant on a displacement versus time graph. And when we slow down, the slope decreases on a displacement versus time graph. Remember that the slope of a displacement versus time graph tells us the velocity. And in a velocity versus time graph, we speed up, so the slope is positive. Then we move at the same speed, the slope is 0. Then we slow down, the slope is negative. When we speed up, acceleration is positive. When we move at the same speed, acceleration is 0. When we slow down and stop, acceleration is negative. Question 2. The car starts from rest and it accelerates at a constant rate of 4 meters per second squared for 8 seconds. What is the speed of the car after 8 seconds? So take a look at these two equations. U is initial velocity, V is final velocity, A is acceleration, T is duration of time. We could solve for final velocity. Part B, how much distance did the car travel during these 8 seconds? Take a look at these two equations. S is the change in displacement. S is equal to S final minus S initial. A is acceleration, T is the duration in time, U is initial velocity, T is duration in time, of time. The car then moves at a constant speed for 12 seconds. Part C, how much distance did the car travel during these 12 seconds? Take a look at this equation again. S is change in displacement, A is acceleration, T is duration of time, U is initial velocity. The car then slows to a stop at a rate of 3 meters per second squared. So that's the acceleration, negative 3 meters per second squared. Part D, how much time did it take for the car to decelerate and stop? Let's use this equation. V is final velocity, U is initial velocity. A is acceleration, T is duration of time. Part E, how much distance did the car travel when it decelerates? So let's use this equation. V is final velocity, U is initial velocity, A is acceleration, S is change in displacement, X final minus X initial. Part F, what is the total time taken for the car to travel? You could go through the problem and see where I got those numbers. Part G, what is the total distance taken for the car to travel? You could read the problem and see where I got those numbers. Part H, use a pencil and ruler, draw a displacement versus time graph, a velocity versus time graph, and an acceleration versus time graph for the car. So, displacement versus time graph, as we speed up, the slope increases. When we're moving at the same speed, the slope is the same. It's positive. And when we slow down and stop, the slope decreases to 0. Velocity versus time graph looks like this. Speed up, same speed, slow down and stop. Acceleration versus time graph looks like this. Acceleration is positive, speed up. Acceleration is 0, same speed. Acceleration is negative, slow down and stop. Question number 3. You are rushing to the train station to catch your morning commute. The train leaves the train station from Rust with an acceleration of 0.6 meters over second squared. You arrive at the station exactly 4 seconds after the train leaves, and you immediately start running after the train with a constant velocity of 8.5 meters over second. Part A. How long after the train leaves the station do you catch up with the train? So let's take a look at this equation. S is equal to the change in displacement, S final minus S initial. U is initial velocity, A is acceleration, T is duration of time. We have an equation for the train. This equation here tells us the location of the train as long as you put in the time. 0.3 T squared. This here is an equation for U. As long as you put in the time, we know exactly where you are. So if we set the displacement of the train equal to the displacement of U, it's going to tell us when the train and you are in the same location. We could use the calculator to solve for this quadratic equation. After 4.82 seconds, you and the train are in the same location. Okay. Another method is to graph both of these using your graphic display calculator. So this is from the website desmos.com/calculator. You see the blue line is you, the red line is the train, and you and the train meet at 2 points, 4.82 seconds and 23.5 seconds. Part B, how far from the train do you catch up with the train? we're going to use this equation. We're going to plug in 4.82 seconds and 23.5 seconds into it. So you catch up to the train at 6.97 meters and 166 meters. Of course, the train is really long, so this problem doesn't make total sense, but as long as you understand the physics. Part C, with what minimum speed would you have to run in order to catch up with the train? So take a look at this equation again. S is equal to S final minus S initial. That's the change in displacement. U is the initial velocity. So for the train, we have this equation. For U, we have this equation. And in the first part, we knew that the velocity was a number. But now we're just going to call this V minimum. So let's set the displacement of the train equal to the displacement of U. Okay, displacement of the train on the left side, displacement of U on the right side. Now we have this quadratic equation, but we have two variables, time and velocity minimum. So let's do this. Let's take this graph here and let's decrease the slope of the blue line until it crosses the red line only once. That gives us V minimum. So from the graph above, decrease the slope of the blue line until it crosses the red line only once. The blue line is now tangent to the red curve. Make sure the horizontal intercept of the blue line is still at time t equals 4 seconds. So I made another line, it's purple. Since the slope is constant, that means the velocity is constant. It crosses the red curve only once. The red curve is the displacement of the train. So we could take the slope to obtain the velocity. So you pick 2 points, and I picked 3, 0 and 20, 75 approximately. Sorry, 4, 0 and 20, 75. And I get an answer of about 4.69 meters per second. So if you run at 4.69 meters per second, 4 seconds after the train leaves, you could catch up to the train once. Take a break and play this video game.